Hi everyone, this is Miss Jennifer from the New Haven Free Public Library, here today to do another awesome science experiment with you guys. So for this experiment, you're going to need a plate, you're going to need some food coloring, you're going to need some dish soap, some milk, and a Q-tip. So the first thing we're going to do is we're going to take our milk and we're going to pour it onto our plate. And you're going to want to cover the whole bottom of the plate, but other than that, so you don't really need all that much. The next thing we're going to do is we're going to take our food coloring, and we're going to put a couple different colors into the middle of our plate. So this food coloring box has 4 colors, so we're going to put each of the 4 colors. We've got some red, some yellow, some blue, and some green. So here's the fun part. Yeah, you see that the food coloring is spreading out a little bit, but you're ready for it to spread out a lot more? We're going to take our Q-tip and we're going to dip it in our dish soap, and we're going to put it in the middle. And it all spreads out. And if I put it on this side with some clean dish soap, but it'll spread out even more. Yep. And if you look, it just keeps going. You can see where the dish soap was right in the middle there. So now what I'm going to do is I'm actually going to show you how the science behind this works. All right, so now that we have seen the experiment, let's actually look at some of the science behind dancing milk. So what is milk made out of? That's the first thing we have to ask ourselves. So milk is a mixture of water, fat, vitamins, and minerals. The milk we drink is produced by female cows. Milk does not have a set chemical composition, but many of the things in it do. This is called a colloid, or a mixture in which very small particles are spread evenly through another. The next question we need to ask ourselves is, what is soap made out of? So modern soap, or modern dish soap, is made out of a bunch of chemicals. But old-fashioned or homemade soap was made predominantly out of lye, which comes from running water through ashes made out of wood, and animal fat that had been purified, so they cooked it to get all the impurities out. Regardless of how soap is made, it works the same way. Soap is made out of micelles. So if you remember when we talked about triglycerides, these work the same way. So the red circles that you see on the screen are hydrophilic. They love to be around water. But the black squiggly lines are hydrophobic. They don't like water. Now the hydrophilic ends are polar, and the hydrophobic ends are nonpolar. And we'll talk about that a little bit. So when you use soap, the nonpolar or hydrophobic ends stick to the dirt and the oil and the fat, and the hydrophilic parts go on the outside to be near around the water, and that's how you're able to move things around. So now we're going to talk about polarity. Now this is a picture of a bunch of different types of molecules and if they're polar or nonpolar. Polarity is all about the charge of a molecule, so positive and negative. So think of a magnet. When you have a magnet, one side can stick to another magnet, but the other side can't, right? So you need to make sure that the same sides are touching. Polarity in molecules is about symmetry. So if a molecule is symmetrical, it's non-polar. So if you look at this one down in the bottom left that has a B on it, it is 100% symmetrical. So when you cut it, it'll fold exactly in half. If it's is not symmetrical, if it's non-symmetrical, it is polar. So if you look at this one in the top left, if you were to fold this in half, it would not be the same on both sides. The last thing we need to talk about is surface tension. Surface tension is when the surface of a liquid is strong. So water molecules want to stick together a lot. And this is why the food coloring in our experiment floats. This is also why some bugs can float on the water. This is why if you were to drop water very carefully on top of it, it'll form a dome. So what happens when we do this experiment? You remember the milk is made up of fat and water. So when we're putting the food coloring, and the food coloring is also made up of water. But once we add the dish soap is designed to attract fat. So the polar parts go around the water and the non-polar parts attach to the milk fat. And that makes it easier to move throughout the water. And that is why the food coloring spreads in the milk. It also changes the surface tension of the milk because now the different fat molecules are not being spread evenly throughout the milk. So that's the science behind what we just did. Some other ways that you can test this experiment is to try different types of milk. You can try using whole milk versus 1% or 2% or skim milk. You could also even try different liquids. Does this work in almond milk? What about water? Like, what will change? And that's a great way to do experiments, because if you remember, when we do science experiments, we always want to ask a question and then test to find out the answer. So this question would be, how does soap affect different liquids? And then you would make your hypothesis and you would say, I think that this will happen, and then you test it. So I hope you have fun doing your science experiments and testing it. If you had a great time and want to do even more science experiments, keep watching, because we're going to be putting out new experiments very soon. We'll talk to you later. Have a good day.